The lecture component is 50 questions. Of those 50, 40 are multiple choice, and 10 are fill in the blanks. And you can think of them as short answers. And then for lab, that will be 30 questions, and they are all identification, and fill in the blank. Or well, we should say name the term, name the structure, and spelling counts. And in this exam, probably more in this exam than ever, make sure that if there's a pair, if there's two of the same structure, to identify whether it's a right or left. Okay. And for both, you'll need to use respondus lockdown. And the webcam. So same thing applies. I can only grade your exam if you did a thorough environmental scan. And can someone tell me what a thorough environmental scan looks like?
Typically what I do is I will scan to either side of me on my lap on me, and then I will turn my laptop so that way it shows everything that I am like in front of me. So that is what I typically do, and it seems to pass the test. So
perfect, exactly. So essentially you just want to show me what you're seeing. So make sure I see the right of you of your table, or wherever you're taking the exam, the left of you and in front of you, and then to the right and left of that as well. So just to kind of rule out, it's more protective reasons for all of you in case the respondus lockdown does flag you. Let's say that, you looked in one, you looked away from the screen versus towards the screen. I can just say, well, I saw their surrounding areas and there was nothing there, so they're good to go. Okay, so make sure you do a really thorough environmental scan instead of just kind of like going up and down. Make sure you go right and left, and I see where your working space is, to the right and to the left of you, and in front of you to the right and left as well. Okay, all right, thank you for that. So exam 3 will include blood, heart, blood vessels, respiratory, and digestive. Okay, so same thing as it always is. It's not that it's going to focus on one thing, but we have a set number of questions for each one, so that it makes sure that you have questions from each section of each chapter. So make sure you do study whatever we've given you in the lecture and in the scripts. Okay. Then I think that's it for the logistics. Does anyone have questions? I see in the chat, no true false. Yes, there will be true false as part of the multiple choice. Any other questions before I move on? All right. So for cardiovascular, that includes the blood, the heart, and the blood vessels. We'll start with blood specifically. So for blood, make sure that you know what the functions are of blood. And can someone just list off some of the functions of blood for me?
Protection.
Okay. Now, yep. 1 second. So when you say protection, in what way is blood protective?
Immunity.
Yes. Okay.
And clotting.
Yep.
Transportation of nutrients.
That's another function. Excellent. Transportation. And we're going to say transportation of nutrients, gases, waste products, pretty much everything. Proteins, lipids, on and on. Okay, great. What's another function of blood?
Regulating.
Thermoregulation, sorry.
You're good.
Okay, yep. So now the thermal regulation is technically a part of what?
Protection.
The heart.
Nope. Thermal regulation is more of a function of the muscles, because when muscles contract, it produces heat. Okay, but you're kind of on the right track. So I love that you add that. So the reason why it's connected to thermal regulation is because in transportation, not only is it transporting the nutrients, the gas, the waste, but it can also transport the heat. So heat would actually be a part of the transportation. Okay, what's another function of blood?
The regulating of pH levels.
Exactly.
Fluid.
Okay, so regulating of pH is one. What's another? Body fluids in general. Water volume in your blood. And if you can regulate water volume in your blood, essentially you're also regulating what?
Blood pressure.
Exactly. Okay, so let's talk through that function a little bit more, just to make sure it makes sense. So here's my bloodstream. Here's my blood vessel. And let's say in that blood vessel, I regulate so that there's only 3 hydrogen ions. Okay, and let's say there's not enough, so I allow more hydrogen ions to enter. What am I influencing by moving hydrogen ions in and out of blood?
pH.
Exactly. Okay, let's say that there's a certain volume of water in blood, and I cause that water to leave the blood vessel. Or let's say I decide I need more water, so I add more water. I allow more water to go into my blood vessel. What does that influence? Well, for sure, water volume, right?
Right.
And then eventually, if I control the water volume, I'm controlling blood pressure. Because the more water that goes in there, the higher the blood pressure is. Okay, so those are some of the main functions of blood. Okay. Now with a component of blood, we can do what's called a hematocrit. And hematocrit takes blood and puts it into a tube. Okay, and puts that tube into a centrifuge. You know, you can lay all the tubes there, and it's going to spin it. And when it spins the vial of blood, the blood's going to be separated based on density. Okay, so the hematocrit spins the blood and separates blood based on density. In other words, what's the heaviest? Density.
Red blood cells.
That's right, and that's why they land in the bottom. Okay, so the red blood cells land in the bottom. Red blood cells. What's another name for red blood cells?
Erythrocytes.
Perfect. And they make up what percentage of blood?
half. A little over half.
Be a little bit more precise.
Is it 51%?
45%?
It's about 55%.
55.
Yeah. Okay. And then you have this really thin layer right here. And what's that thin layer called?
I thought the RBCs only had 45%.
Oh,
45%.
you're right. Because the most abundant is plasma. You're right.
Mhm.
Yeah, it's
Thank
like
you.
1 or something.
Yep. So what's this yellow one right here?
Platelets.
Yep, it contains white blood cells. We call it the Buffy coat.
Buffy coat. That's the word I couldn't think of.
Yep. And you're right. In the Buffy coat, you will find white blood cells. And what's another name for white blood cells?
Leukocytes.
Mm-hmm. Yep, leukocytes. And in another slide, we'll work out the different types of leukocytes. Okay. For now, we have the white blood cells. And then you will also find what else in this layer. Sorry, someone keeps moving.
Platelets?
Platelets, very good. Okay. And that leaves the most abundant layer. Thanks for catching that. Let's do this right here. What would that be?
Plasma.
Plasma. And plasma makes up what percentage?
55.
Yes. Okay. And the Buffy coat would be less than 1%. And that makes sense because the Buffy coat contains all your protective. You want some there, but you don't want it to be in abundance because if it's higher than 1%, what does that tell you?
Extra clotting factor in the blood, I guess.
Yeah, that's right. So you either have trauma that requires more clotting factors such as platelets, or you have an infection. So that's how when you go to the doctors and they take your blood sample and they say, oh, your neutrophils are elevated, which means that type of white blood cells high, more high than what the average range is, which means that you probably have some type of bacterial infection. Okay, so you want the Buffy coat to be very little. You want some there in case something does get into your body, but you want it at low levels because if it's high, it's an indicator of infection. Okay, and plasma is the most abundant at 55%. Buffy coat is less than 1%, and that leaves red blood cells as 45%. Okay. Now, we do categorize the components of blood in another way as well. So we categorize it based on what's there. But another way to categorize the components of blood is based on solid versus liquid. And what's the solid components of blood?
Or blood, the red blood cells, white blood cells.
Yes, ma'am. And one more.
Platelets.
Yes. Of these, how many of them are cells?
Just
Two.
two.
That's right. So platelets used to be called thrombocytes, clotting cells, but we know that they're not cells. Platelets are fragments of a larger cell called megakaryocyte. So if I ask you on the test, true or false, platelets are clotting cells, you would say
False.
that's correct. Okay. All right. But these are the solid components of blood. That leaves the liquid component of blood being plasma. And the reason for that is because plasma is mostly what?
Water.
That's right. Very good. Okay. So we can go through these four components of blood in a lot more detail. Any questions before I move on? So in red blood cells, we know that they're also called erythrocytes. We want to make sure you know the function of red blood cells. We know the function of blood in general, but each component here has a specific function. So red blood cells has a specific function, it has the structure, and it has the life cycle. So you want to make sure you know these three components. Would you like me to cover these or move on to the areas that you requested?
Will we need to know all the specific proteins in the plasma?
Absolutely.
Okay.
Cover, please, if time permits. Okay, let's go through them. If I don't have time to cover this whole review session, I do have an evening session that I could kind of push it into that one and then record that session as well. Okay. So anything you want me to cover, let me know and I'll cover whatever I can. All right. So functions. Can someone remind me what functions of red blood cells are?
Carry oxygen.
Ah, that's
Hemoglobin.
one thing it carries, but what else? It transports gases in general, right? And you're right. One of those gases is oxygen. What's the other gas?
Carbon dioxide.
Carbon dioxide.
Yes, ma'am. That's right. Okay, so keep that in mind as we go through the structure and connecting functions. Okay, so let's go through the structure. What words would you, if I were to ask you about red blood cells, what word would I use in terms of structure?
Biconcave.
Very good. Keep going.
Discoid.
Mm-hmm. Excellent. So in terms of the structure, it looks like a donut. It's biconcave, it's discoid, which means that in the center, it is what? It's hollow, right?
Hollow.
What would normally be in the center of a cell?
Nucleus.
Right. So what does that tell you about a red blood cell?
That it has
Doesn't have
no-
one.
Mature red blood cells do not have a nucleus. And that's why, in terms of their life cycle, how many days, how long can they exist?
120 days.
That's right. As the red blood cells pick up the oxygen and the carbon dioxide and transport it, as it's moving through the blood vessels, goes in and out, it has to squeeze in and out, right? It's going to get damaged. And because it has no nucleus, that means no repair, no cellular repair. And that accounts for why they only last for 120 days. Okay. In addition to that, a mature red blood cell does not have what?
DNA.
Mitochondria.
Oh, mitochondria.
You're right with the DNA. So if it has no nucleus, it's not going to have the DNA inside the nucleus. And that's why it can't repair itself. Your classmates are also right in that it does not have mitochondria. Remind me, what does mitochondria do?
It's ATP.
Produces ATP. How do you produce the most amount of ATP?
Multiple mitochondria.
Okay, so if you have the mitochondria, what does it need to produce a lot of ATP? What pathway?
Oxygen.
It needs oxygen by aerobic respiration. But the problem is that aerobic respiration uses O2. And what did we say the function of a red blood cell was to do?
Carry it.
It's supposed to carry it. How effective would a red blood cell be if it's using what it's carrying? So by the time it gets to its destination, let's say half of what it's supposed to be carrying is consumed. That wouldn't make sense, right? And that's why red blood cells, because their function is to carry the gases, you don't want them to consume it. And that's why a mature red blood cell does not have a mitochondria. Does that make sense?
Yes.
Okay. All right. So now we break down the red blood cells. What are the functional units of a red blood cell? What's the functional unit of red blood cells? They have thousands of these units inside of a red blood cell. I heard someone say it earlier.
Is it hemoglobin?
Yes, ma'am. Hemoglobin. Okay. I'm going to save the hemoglobin for a little bit because when I talk about the life cycle, we'll break down the hemoglobin. And by breaking down the hemoglobin, we'll also talk about it. Okay. All right. So now we're ready to do the cell life cycle. And a lot of you did beautiful discussion videos in terms of hypoxemia. Hypoxemia is a really nice example of how that incorporates the life cycle. Okay, so what is the life cycle of a red blood cell? First of all, let's start with where are they produced?
Red bone marrow?
Yeah, produced in bone marrow. Okay. Once they're produced, they're going to survive for how long?
120 days.
Mm-hmm. And at around 120 days, what's going to happen to them?
They start to break down.
Yeah. And what catches them?
Is it like the liver?
Yes.
What
The
I said.
liver and what?
Spleen.
Yes. And that's why the liver does a lot of things. And that's why it's called the liver, because you can't really live without your liver. But the spleen is also known as the graveyard of red blood cells. Because the spleen it has these kind of a fibrous tissue, like a mesh, that catches the damaged red blood cells and then breaks them down. Okay. So in about 120 days, the red blood cells break down and they're caught by the liver and the spleen. And when they break down, they're going to break down to their functional units. And we just learned that the functional units are hemoglobin. Okay, so let's go further with that. Let me see if I can expand this a little bit so I have a little bit more room. Okay, so hemoglobin has two main parts. What are the two parts of hemoglobin?
Iron or the hemoglobin, but
It's got the heme groups. There's 4 of them. And it's got the globin chains. What are the globin chains made up of?
Protein.
Yeah. And proteins are made up of what?
amino acids.
Yes, ma'am. So the globin chains will be broken down to proteins, because that's what the globin chains are. And then the proteins will be broken down to amino acids. And then the amino acids are reused in your body. Okay. The 4 heme groups. The heme groups look like a pinwheel almost. Okay. So there's 1, 2, 3, 4. So there's 4 heme groups. Each heme group will have an iron attached to them. Why iron?
Is it for blood formation?
Nope. So with a rusty car, I'm sorry. So a car that's made up of metal, okay? Over time, it gets rusty, right? What's the car made up of? Iron, right? And we didn't have to do anything because over time, iron is going to bind to oxygen, and that's what leads to that rust that occurs, okay? So the reason why I'm giving you that example is to show you that of all the elements, iron has a really high affinity for oxygen. In other words, it binds to oxygen pretty readily, okay? So that's why in addition to the heme group, you must also have 1 iron per heme group. There's 4 heme groups altogether. 1 iron binds to each heme group, and that's what allows for oxygen then to bind to the iron. Okay? Questions? So in 1 hemoglobin, how many molecules of oxygen can be carried?
1.
In 1 hemoglobin, how many molecules of oxygen can be carried?
Is it 4?
Yes,
4, yeah.
that's
4.
exactly
Oh.
it. Because 1 hemoglobin has 4 heme groups. Each heme group has an iron, and iron binds to a molecule of oxygen. So that means that each hemoglobin can bind to 4 molecules of oxygen. Okay, so overall, the function of the heme group is to bind to oxygen. Bind to oxygen. And what exactly is binding to the oxygen?
Iron.
Yes, ma'am. All right, so at least the globin chains. The globin chains, we know that they break down to protein, to amino acids, and that can be reused, right? But the globin chains function in carrying what?
Carbon dioxide.
That's right. Okay. All right. So I'm going to break the heme group down further. So we established that in the heme groups, you've got the heme and you've got the iron, right? Anyone follow that far? Make sense or no?
Makes sense.
Thank you. Now the iron can either be reused or it can be lost in menstruation. And that's why women when they're having their periods, they can undergo what?
Iron deficiency.
Yes. What do we call that?
Anemia.
Anemia.
Yeah. Perfect. That's right. Okay. The heme is a pigment. And this pigment is actually going to travel to the liver. And when it travels to the liver, it's going to go through a series of change. Biliverdin to bilirubin to bile. Have you heard of bile before?
Yep. Gallbladder.
Become bile. Okay. Now, if the liver is damaged or not functioning, the heme group is going to go to the liver. And if it's not processed into bile, it stays in the bilirubin state. And in the bilirubin state, if it accumulates, it can cause your skin the sclera of your eye to become what color?
Yellow.
Yellow, that's right. And that's why premature babies who have underdeveloped liver can be a little yellow. Or jaundice, very good. Or someone who's alcoholic and has damage to the liver, if it's severe damage, it will eventually cause their skin and sclera to turn yellow, also a form of jaundice. Okay? Hopefully giving you these connections to real life situations help you to remember that the heme is a pigment that travels to the liver to become bile. And it goes through those stages of biliverdin to bilirubin to bile. And then the bile plays a role in the digestive. Okay? Does that make sense?
Yes.
Okay. So eventually the hemoglobin, which is a pigment, which is, by the way, why when blood is oxygenated, it's what color?
Blue. No.
Oxygenated.
Red.
Red.
Red. Because in blood, in the red blood cells, they have the hemoglobins, and the heme is a pigment. So when oxygen binds to that pigment, it becomes red. Because heme is a pigment. And then if it is broken down, goes to the liver, it will become yellow. Because again, it's still a pigment, a color. Okay? All right, questions before I move on? Well, look at this. I had a whole slide for structure of life cycle and I did not use it. All right. So in that teeny weeny little space, we made room for that. All right. So then that was red blood cells. Then you have plasma. Make sure you know the function of plasma, the components of plasma, and the plasma proteins. Since I had questions about the plasma protein, I'm going to spend a little bit of time on that if that's okay. You can look up the function. Let's go through the components. Plasma is mostly what?
Water.
Water.
Yep, mostly water. It's got hormones. Whatever blood carries, it's going to be found in plasma. That includes hormones. It's going to include gases. It's going to include nutrients, waste, and so on. Okay, but one of the components that we're interested in looking at is the plasma proteins. There's a lot. There's a long list of all the plasma proteins you can find. I just want you to know the main ones. There's 3 of them. Can you name those 3 for me?
Albumin.
Yes, ma'am. Give me a second to write it down. Yep, albumin. What was the other one?
Fibrinogen.
Fibrinogen. What's another one?
Globulin.
Globulin. Yeah.
Okay. So albumin, if you know someone who has to go through paracentesis, so it has to, like diabetics, people who are on dialysis, and so on. What happens is that their tummy, the abdomen, fills up with water, so they have to go through paracentesis, where they pull the water out. And when they pull the water out, they also pull albumin out. And albumin is what helps to kind of control and regulate the amount of water that you find in blood. And that's why if you have like someone you know, or if you are in that occupation, you would give that patient albumin to kind of put back what you took, so that they can better regulate the amount of water in blood. And the reason for that is because albumin functions in osmolarity and viscosity. Osmolarity and viscosity. What do those terms mean? Osmolarity means what? How much water is being moved? Okay, so albumin controls how much water is being moved, whether it's in or out of the blood vessel. And because it controls osmolarity, of course, it's going to control viscosity, which is the thickness of blood. So osmolarity and viscosity go hand in hand. And it's all associated with what plasma protein?
Albumin.
Yep. So sometimes, I know it sounds really silly, but sometimes it helps to say the words out loud so you remember it more. So can you say it with me? Osmolarity and viscosity.
Osmolarity and viscosity.
Thank you, ma'am. All right. So osmolarity and viscosity is associated with albumin. And the reason why is because albumin functions in controlling how much water moves and the thickness of blood. Okay. Then you have fibrinogen. Here's a medical terminology. Anytime you see the term ogen, and you've seen it more than once already, you saw it in digestive system as well. Anytime you see the term ogen, it means inactive. It is the inactive form of that substance. So fibrinogen is inactive. Is that a good thing or a bad thing that you have fibrinogen, an inactive form in your blood? Normally.
Probably good.
It's good because you don't want to be having blood clots as you're just sitting there doing nothing, right?
Mm-hmm.
So you only want it to be in its active form when you need it. In other words, when there's trauma, let's say you accidentally cut your arm or something happens, right? So you want it to be in its inactive form. And that's why you see the term fibrinogen, inactive. When you have a cut, it turns out that on the outside of a blood vessel, there's another chemical that will go in and convert the fibrinogen into what? It's just a fibrin. So you just remove the word ogen out, then it becomes active. Okay, so it's fibrinogen. It's in its inactive form, and when it gets catalyzed, it's going to become fibrin, and it's actually fibrin that leads to blood clots, which makes sense. So here's fibrinogen. Here's your blood vessel. Here's fibrinogen. Okay, let's say you get a cut, and then there are enzymes out there that when you have a cut enter into your bloodstream and activate the fibrinogen into fibrin. And that's what leads to the clotting, which makes sense because if you have a cut, you want to be able to close up that cut. Okay, so that's fibrinogen. It's found in plasma as a protein. It gets activated and becomes fibrin when there's trauma that converts it from fibrinogen to fibrin. And what does it do? It forms clots. Okay. The last one is really interesting actually. Globulin. So the globulin is a plasma protein. In other words, it's a protein that you find in plasma. It's also known as immunoglobulins. And you can think of these as antibodies. Okay, so true or false? Antibodies are cells.
False.
False. What are they?
Excuse me. Proteins?
Yes. And where do you find these proteins?
In your bloodstream?
Yeah. In what component?
I guess it's globulin.
In plasma.
In plasma.
Yeah. Okay. So that's another thing that students often make a mistake with. Whenever I ask, and this has been a test question in the past, true or false, antibodies are cells, they say yes. It's not, right? Because if antibodies are immunoglobulins, and immunoglobulins are globulins, and globulin is a plasma protein, it is not a cell. It is a protein that is found in plasma. Okay. All right. All right. So that's kind of plasma in a few minutes. Okay. Spend more time kind of getting more of the details, but I'm just giving you kind of the big picture. Then we're going to move on to leukocytes. A nice mnemonic to remember is never let monkeys eat bananas. It's great because it allows you to remember it from most abundant to least abundant. Okay. So never let monkeys eat bananas. That means that the most abundant is
Neutrophils.
yes, neutrophils. And the second most abundant?
Lymphocytes.
Yes, ma'am. Neutrophils, lymphocytes. Next.
Mono.
Monocytes, followed by
Eosinophils.
Then basophil.
Yep. Now, as you're studying, you want to make sure, since these are white blood cells, right? They function in protection. You want to be able to figure out what they are protecting you from. Okay, and I'll help you start this list. Make a cognitive map so that you can see all on one page, kind of a summary of what they are and what they do. This is much better than writing it in like paragraph form because one, it allows you to recall much easier on the test. It's less anxiety, easier to pull and recall. Okay, so neutrophils fight against what mainly? See, you gotta know this. I heard it, bacteria. So on the test, I asked you, which of the following leukocyte responds to bacterial infection? You would say neutrophils. Okay. All right. And then, so that's what they respond against. Okay. And in this next column, I want you to tell me how. So neutrophils are able to respond against bacterial infections because they are phagocytes. What does phagocyte mean?
They eat it.
Yes, ma'am. That's right. They eat bacteria. Okay. So I want you to do something similar with the rest of them. All right. Because I want to spend my time talking about the heart because that was one of your requests. Okay. Before I move on though, another good mnemonic to remember is Benji. Because we classify these white blood cells, these leukocytes, also based on whether they are granulated or agranulated. Okay. Very simple, just pure memorization. On a test, you might see a question. Monocytes, lymphocytes, and neutrophils are agranulocytes. True or false?
Can you repeat that again?
Yes, ma'am. Monocytes, lymphocytes, and neutrophils are agranulocytes. True or false?
True. No, because of monocytes. Oh.
It is false, but monocytes and lymphocytes, both of these are agranulocytes. Because remember, Benji. So Ben means basophil.
What's the Benji stand for?
Huh?
I was wondering what the Benji stood for.
Yes. Basophils, eosinophils, and neutrophils are granulocytes.
I see.
Yep.
Okay.
Yep. Okay. So really, I can guarantee you there will be at least one question on this. Okay. And let me see. 1 second. That time? Okay. I have a few minutes left before I have to go to a meeting. And that's why I'm going to continue this in the second half. Okay. I have 10 minutes. Oh, okay. I have time for the heart. Okay, let's do the heart. All right. So the best way to, well, not the best way, one way to do this, and you can do it multiple ways, and you find the way that makes sense to you. For me, how I learned this is I just drew the heart. And after you do this enough times, you will do just like I am doing it. Like do, do, do. Okay. I promise you, if you do this enough times, you will be able to do it just like me. Even better. Okay, so really the best way to do this is just to draw it out and label it. And if you can't draw it out like this, then draw it out like this. It's the same thing, right? It's about having 4 chambers and like that. Okay. And just going through it. And as you're going through this, I would do it in 2 ways. 1, in terms of what structure are correlate with each other, and 2, in blood flow. So let's do it first in structures that correlate with each other, and then we'll do it again in blood flow. Okay. So in terms of structures that correlate with each other, first, I would do the chambers. What chambers do you have in the heart?
Atrium.
Mm-hmm.
And
And
ventricles.
yes, ma'am. Okay. So what would this one be?
Wait.
Can you see my pointer?
No.
No,
How's that? Here we go.
there. Right atrium.
It's the right
Very
atrium.
good.
Yeah.
And that makes this the
Left atrium.
atrium. And you know what? Because I do allow a piece of paper on the test, a blank piece of paper, the minute you start on the test, I would just, if this is my paper right here, sometimes it just helps me, oops, sorry, I meant to write with that. Sometimes it helps me just to divide it and write down left, right. Because it's mirror. It's not, you're looking at it versus the way your body is positioned. Because a lot of students on their quizzes got this one wrong. They put a left where it's a right and a right where it's left, because you're basing it on like how you're looking at it and not how you would be if you were in that position. Okay. So just right away, make yourself a reminder that everything on, and I made the same mistake that most students do. What did I do?
You put left on the left.
Mhm.
That's right. Okay. Because you have to remember your body has to be in that position. So your right is actually the left of whatever you're looking at. And your left is actually the right of whatever you're looking at. Okay? All right. Okay. So you have the atriums, which are on the top, and then you have the ventricles, which are, oops, wrong color. Ventricles, which are on the bottom. Okay? So those are your chambers. And it helps if you add what they do. Atriums receive the blood. Ventricles pump blood out of heart. Okay? And then The next thing are, let's do the valves. There are two types of valves. What are the two types of valves? You've got the AV valves and the semilunar valves. It's easy to be able to distinguish them based on just their names, right? The AV valves tells you that it's between the atrium and the ventricle. So here's one. Let's do a different color. And here's another one, between the atrium and the ventricles. Okay, there's two of them. There's one on the right and one on the left. Okay, so on the right, there's three of them. This valve, the AV valve, has three cusps, these three flaps. Okay, and that's why we call it tricuspid. So you can either call it the right AV valve or the tricuspid valve. Because here's another way to remember, you try before you buy, okay? Now these AV valves, because of these flaps right here, if there's enough pressure, these flaps can fold upwards, right? So what you will find always associated with these flaps are these strings. What are these called? Tendinous cords, right?
Cords, yeah.
Yep. So always associate with just the AV valves because they have these flaps. They have these tendinous cords. And then the tendinous cords have to be attached to the papillary muscles. Okay, to hold it down. So if the pressure pushes it up, it closes but doesn't open up on the opposite side. Now you can see on the left-hand side, how many folds are there?
3.
On the left-hand side, right? Yeah, on the left-hand side, how many folds are there?
2.
2. So you can either call it the left AV valve or the bicuspid valve. And to make it a little bit harder, we also call it the mitral valve. Okay, so on the test, you would not say the left bicuspid valve because you only have one bicuspid valve. Nor would you say the left mitral valve because you only have one mitral valve. But if you are going to say the AV valve, then you have to indicate right or left. Make sense?
Mm-hmm.
Yes.
Okay. Now the semilunar valves look like this. Semi meaning half, lunar meaning moons. So these are little like clips right here. Little cuspid, little, they're not flaps, but they're like half moon shapes right here. No flaps, so they don't need the tendinous cords. Okay, so semilunar valve, which means that this right here is a semilunar valve. And this right here is a semilunar valve. Okay, so the first one, right, let's do the one on the right. So the one on the right, this semilunar valve right here.
Pulmonary.
Yeah, how? Why?
Because it goes to the lungs.
Yes, beautiful. Love it. Thank you so much. How about this one?
Aortic.
Very good. That's exactly it. That's how you name it based on what it's connected to. Okay. And then the third thing that you want to do are the blood vessels that are associated with it. Just move this up here. Okay, so this morning we went through the beginnings of exam 3. Everyone that's here, were you here for the morning session?
Yes.
Yep. Okay. Well, then instead of reviewing everything, I'm just going to continue where we left off, which is structures of the heart and blood flow. So let's do that. Let's delete that. Delete that. Okay. My laptop. Okay. So when you're learning about the parts of the heart, it's really helpful to draw it out. And if that's like something you really don't like to do, then you can do a template of it. But I find that if you draw it out, you kind of have to force yourself to know it a little bit better. What happened? Okay. I don't like that color.
What did I do? Mm-mm.
Okay. All right. So we'll start with identifying it by kind of the structures that are similar to each other. So like I said last time, we'll start with chambers. So you have a right and left atrium. And these are on the top. And they're on the top and they receive the blood. Okay.
I'm sorry, my son's laughing at
I think it's adorable, so it's all good.
He's watching his tablet. He's laughing at his tablet.
Aw, this is too cute. So this is the, yeah.
That's his life right now.
Ah, so that's the right atrium, and this is the left atrium. Then you have the ones below, the right and left ventricle. And these are always on the bottom. And they pump the blood out of the heart. I try to do two things at once instead of just memorizing the structure. I also add function to it because you'll need to know both anyways. So pumps the blood out of the heart. So this would be the right ventricle and this would be the left ventricle. So those are the chambers, okay? Then you have the valves. There are two types of valves. There's the right and left AV valve. And the right and left AV valve are characteristic in that they have these little flaps, whether it's two or three. And because they have these flaps, always associate with the atrioventricular valves, you'll find these tendinous cords. And what holds those tendinous cords down are papillary muscles. Okay, so you have the right and left AV valve. And if you want to be specific, the right one is also called what?
Tricuspid.
Because it has three flaps.
I got that back earlier.
Yes. And see, that's the great thing though, is that if you make a mistake here, you're more likely to remember it. And then the left one is the bicuspid. It's unfortunately also known as the mitral valve. Lots of names for the exact same structures. I did not make that up. I don't know why, but that's just how it is. Okay. So on the test, if you write either the right AV valve or the tricuspid valve, either way is fine, but there's no right tricuspid valve. Okay, so make sure that you are attaching the sequence of the name correctly. Then the other set of valves that we have are the semilunar valves. And the semilunar valves are just like their names, half moons. So they look like this. Okay, and that's one here. And there's one here. Okay. So depending on which one, if we're looking at the one on the right-hand side, because it's attached to the pulmonary trunk, we call it the pulmonary valve. It's technically pulmonary semilunar valve because that's such a long name, we just shorten it to pulmonary valve. And then on the left side, we have, because the left side is attached to the aorta, we call it the aortic valve. Okay, so this one right here would be the right AV valve, and these structures right here would be the tendinous cords. And then attached to those tendinous cords to anchor them down would be the papillary muscles. Okay, where on this side we have the left AV valve, and same thing, they would be the tendinous cords that link them down along with the papillary muscles. Okay, where this one right here, because it's attached to this blood vessel, that makes it the pulmonary valve. And this one, because it's attached to the aorta, we call that the aortic valve. Okay, so those are the valves. The more difficult ones are the blood vessels. Before we start on the blood vessels, we need to know the difference between arteries and veins and capillaries. So just remind me, what are arteries?
Take blood away.
Yes, it's always going to move blood away from the heart. And A in artery for A in away. Where veins move blood towards the heart. And capillaries allow for exchange. Okay, so really we're going to be looking at the arteries and veins of the heart. Okay, and when we're doing these, we're just going to follow blood flow. Gonna get two things out of the way. Okay, so we'll start with how blood enters into the heart. How does blood enter into the heart?
The subclavian.
Not the subclavian.
Oh, I mean
Which one? Say that one more time, sorry.
the superior and inferior vena cava, sorry.
That's correct. Yep. Yep, no, that's good. So here, up here, let's color that in. Now, would those be oxygenated or would that be deoxygenated?
Deoxygenated.
Right. Okay, so the ones that I've colored in will be, we'll call it 3A. Actually, we'll do, how do we make this more sense? Let's do A1 and A2. Okay, and under here, I'm going to have A as the vena cavas. And then 1 would be superior. 2 would be inferior. Okay, so now the deoxygenated blood, change my color, blue, is going to move into what chamber?
Right atrium.
Yep. Okay, and then from the right atrium, it passes through what structure?
The right AV valve.
Very good. And from the right AV valve, it enters into the
Right ventricle.
very good. And then it passes through this valve, which is the
Pulmonary valve.
very good. So now we come to our next blood vessel. So this next blood vessel right here, that I'm going to shade in just this portion though, okay? Just up to here. What would that be?
Pulmonary trunk.
Very good. So I'm going to call it B, the pulmonary trunk. And the pulmonary trunk, is that an artery, vein, or capillary?
Artery.
Yes. Why?
Because it's taking blood away from the heart.
Very good. And the reason why it's called a trunk is because it's going to branch. Anytime you hear the term trunk, it means it's going to branch. And it does. So from B, it's going to branch into C1 and C2. So what's C1 and C2?
Yeah. Left and right lung.
No.
All
Where?
the pulmonary
These are the pulmonary arteries.
arteries.
Yep. 1 is which side?
Right.
Mm-hmm. And 2 would be left. Does that make sense?
Yes.
Now I'm going to color that in. So we finished that blood vessel, or those sets of blood vessel. Now it goes into the lung. Okay.
Yeah. I gotta
From
hit
the
them.
lung, yep. From the lung, it's going to go back into the heart through what blood vessel?
Pulmonary veins.
Yeah. So you've got D1 and D2. One coming from the right side and one coming from the left side. I did not leave myself much room. D, so it would be the pulmonary veins. And 1 would be the right, and 2 would be the left. Okay, so from there, is it going to carry oxygenated or deoxygenated blood?
Oxygenated.
Yeah, at this point, it picks up the oxygen from the lungs. So it's going to go from the lungs through the pulmonary veins into what chamber?
Left ventricle.
Atrium.
Which one?
Left atrium.
Left atrium. From the left atrium, it's going to pass through what structure?
Left
Mitral.
The mitral valve, or what's another way of saying it?
Left AV or bicuspid.
Yep. And it's going to enter into what chamber?
Left ventricle.
Very good. And then it's going to go through what valve?
Aortic.
Yep. And that brings it to this next blood vessel right here. Okay. And this next blood vessel right here has 3 parts. Okay, so let me label it and then I'll have you tell me what it is. It's D, so E1, E2, and E3. F3. What is E in general?
Aorta.
Mm-hmm. What is E1?
Ascending.
Mm-hmm.
Aorta.
Yes, ma'am. 2?
Aortic arch.
Very good. Okay. 3?
Descending aorta.
Good. Okay. And almost done. From E, we're going to have D. So off of the arch of aorta, or the aortic arch right here, we have 3 branches. 1, 2, 3. So I'm going to call that DEF 1, 2, and 3. Here's F1, F2, and F3. What's F1?
Brachiocephalic trunk.
Yep. F2?
Left common carotid.
Yep. F3?
Left subclavian.
Oh, you make me so happy. Exactly. And that's it. That is all there is to blood vessels. That's it to the heart. Account for the chambers, account for the valves, and account for the blood vessels, and you're good.
Cool.
Yep. Okay. Questions? So let's do that again with blood flow. Okay. Whatever, if I were to follow a molecule, let's say if I were to follow a red blood cell as it moves through the heart, how does it enter into the heart, and how does it exit the heart? Let's go through it step by step. So if we were to look at blood flow,
Mm-hmm.
follow one red blood cell. What's the first thing the red blood cell will encounter in order to get into the heart?
The vena cava.
Yeah. Mm-hmm. And then?
Right atrium.
Mm-hmm. Keep going.
Right AV valve. Right ventricle.
Mm-hmm.
Pulmonary vein. I'm sorry, artery. Pulmonary artery. Oh, well, maybe I was right the first time. The trunk. Well, I guess it gets to go through the valve first, right?
Yes, there you go. It's gonna go through
Whoops.
the valve first, and then you're right. The pulmonary trunk. And then it becomes the right and left pulmonary what?
Artery.
Mm-hmm. Very good. And then it goes into the lungs. And then comes back through the right and left.
Pulmonary veins.
Yes, ma'am. And then it enters into the
Left atrium.
passes through the valve.
Left AV valve.
Gets into what chamber?
The left ventricle.
Left.
Yeah.
Goes through what valve?
Aortic.
Passes through what blood vessel in general?
Aorta.
Yep. And that brings it to the body. And then it repeats. Pretty straightforward, right?
Good.
Yeah, all right. So the cardiac conduction and EKG, a lot of you did wonderful videos on that, so I'm not going to cover that because that's pretty straightforward. And then for the blood vessels, I recommend making a cognitive map of it, and it's going to look something like this. Okay. Now, I left comments on your videos because sometimes some of the videos were very covered a nice introduction, but didn't get really deep, and you need to get into the layer level. Arteries, we know, carry blood away from the heart, but what else? We know it has a tunica interna, it has a tunica media, and it has a tunica externa. Okay. And that's when we can look at the unique characteristics. So it turns out that arteries have a really thick tunica media, and the tunica media is the smooth muscle layer. And the reason why is because it has to withstand high blood pressure, because it's what's moving blood away from the heart, and the heart is generating the blood pressure. If arteries were thin, it would rupture and we would die. And that's why it's structured the way it is, because it connects function to structure, hence giving us the unique characteristics of arteries. Okay, so same thing for veins. Veins carry blood towards the heart. Yeah, we know that. We know it also has the three basic layers, interna, media, and externa. But what's unique about that is that the smooth muscle layer tends to be really thin. Why? It doesn't have to withstand high blood pressure. Okay, so there's very little blood pressure in the veins. So if there's little blood pressure in the veins, what helps it to move? Well, what's unique about veins is that it has valves. The valves, along with the skeletal muscle contraction, help to move blood towards the heart against gravity. Okay. And then you'll find one more for capillaries down there. Okay. Questions? All right. Then for the respiratory system, someone, what was their question on this now? I can't remember. I wrote it down. Hold on, let me grab my paper, my notes. Respiratory.
I think somebody said gas exchange.
Gas exchange. Okay. Okay.
Early, I think that's what they said.
Yeah. I can't remember, so we'll just follow what you said. Okay. So the respiratory system, I think, in my opinion, the hardest thing is kind of understanding the tissue lining with the tissue structure. Okay. So that's why in the worksheet that I have you do, if you don't do the worksheets, you should take a look at them, because I created a cognitive map for you that lists the structures of the respiratory tract, and then you had to identify the lining of it and then the function. Oops. Okay. So definitely go through that before you take the exam. So for example, the mouth, let's see. The nose is lined with pseudostratified columnar epithelium. Where part of the pharynx, the oral pharynx, for example, is lined with squamous, stratified squamous. Because stratified squamous can handle abrasion, where pseudostratified columnar epithelium cannot. And that's why you find it in the mouth, because you eat, you drink. Okay. So when you're studying this, the lining of what you find in a certain area should make sense, because it depends on what is moved through that opening. Is it just air, or is it food/water? Wherever you have food and water, it's not going to be pseudostratified. If it's air only, most often it's going to be pseudostratified, at least for the upper respiratory tract. Okay, so that helps take away the memorization and moves it into like, oh, that makes sense. Okay. And if it's something difficult for you to do, I did link a lecture video to that where I go through all of that. Okay. With ventilation, that's the inspiration and expiration. Okay. I kind of want to go through that because some of the videos had errors in it. So let me take a little bit of time talking about the ventilation. So in ventilation, there are two main things you have to know. What are the two main key things in ventilation that you need to know?
Mm.
You need to know Boyle's law. What's Boyle's law?
When the volume of a space expands, the pressure decreases.
Perfect. Volume increases, pressure decreases, and vice versa. Volume decreases, that causes pressure to increase. Absolutely. And then you need to know about diffusion. Things always move from where to where? Naturally.
High to low.
Yes, ma'am. Okay. So in some of the videos, students were talking about how when you breathe in, that causes your lungs to expand. Is that true?
No.
No, it's not. It's your body creating the environment that either forces the air in as a vacuum or pushes it out. Okay. So it's not like a balloon where you blow the air in and the balloon expands. No. In the body, ventilation is based on this two key muscles. What are they?
The
And
intercostal muscles.
yes, ma'am. Okay. So between these muscles, they're going to change the volume of your thoracic cavity. And by changing the volume of your thoracic cavity, it changes the pressure. And it's the change in pressure that causes diffusion to happen. Okay. So let's say, for example, here's my diaphragm. Let's say, if it contracts, what is this diaphragm going to look like? Is it going to be below the original line or above the original line?
Below.
Yeah, it shortens. So when it shortens, that's contraction, right? Contraction always causes things to shorten. Okay, so it went from being this length, the original black line, to this red line. So when the diaphragm contracts, what does it do to the space? Does it increase the volume or decrease the volume?
Increase.
It increases the volume. So volume increases. And if volume increases, what then happens to the pressure inside the lungs?
Drops.
It drops. So when you compare the pressure of the lungs to the atmospheric pressure, which is higher?
Outside pressure.
That's right. Outside pressure, it doesn't change. It's about 750, 760. There you go, 760 millimercury. When the volume increases and the pressure decreases, it's actually going to go all the way down to 756. And we just mentioned that diffusion goes from high to low, right? So the air is sucked in, is vacuumed in, and that's what leads to inspiration. Okay, so a few students said that the air comes in, expands your lungs. And that's not what happens. It's actually your lungs expanding that sucks the air in. Okay. And then if it did the other way, if your diaphragm lengthens, gets even longer, it's going to push upwards. And when it pushes upwards, what does it do to the volume?
Decreases.
Yeah. Volume decreases, and if volume decreases, what happens to the pressure?
Increases.
And it actually gets around 763, at which point now it's higher than atmospheric pressure, so it pushes the air out. And that is what happens in in expiration. Okay? So it's not like a balloon where the air goes out and then the balloon shrinks. Okay? So that's ventilation. So hopefully, because there's going to be a test question that asks you the sequence of what happens or what has to happen in order for inspiration and expiration to occur. Okay, so you have to understand that it's a change in your thoracic cavity that then creates the environment that either vacuum sucks in the air or pushes it out. Okay, all right. Gas exchange was the other one. So under gas exchange, twice. It occurs twice. When does gas exchange occur in the respiration system? You have the pulmonary and you have the systemic. Okay. So we're looking about inside the lungs. Where does gas exchange occur?
Alveola.
Exactly. In the alveoli.
Out there, there's the word.
Okay. And then you've got blood vessels bringing it to. Oops. Your blood vessels bringing blood to the lungs or to the alveoli. Diffusion happens, and when it leaves, go back to the heart. Okay. So you have the pulmonary veins carrying the blood back to the heart, and you have the pulmonary arteries carrying blood away from the heart to the lungs. Now, this is well, not the only time, but one of the few times in which it is not oxygenated or deoxygenated. 99% of the time, arteries are oxygenated and veins are deoxygenated, but not all the time. And that's why you cannot say that a definition of an artery is that it carries oxygenated blood away from the heart. 99% of the time that's true, but not all, so we can't use that. The only thing we can say for 100% sure is that arteries carry blood away from the heart. Does that make sense?
Mm-hmm.
Mm-hmm.
Okay, so this is the 1 time, 2, 3 times that's not true. Okay, so in this case, the pulmonary arteries are deoxygenated and the pulmonary veins are oxygenated. Okay, so the gas exchange occurs in the lungs. Okay, so let's take a closer look at this. We have what's called the respiratory membrane. you have the lining of the blood vessel, and then you have the lining of the alveoli. And then you have kind of the basement membrane in between. Okay. So the gases, CO2, is higher in the pulmonary arteries than it is in the alveoli. So CO2 is going to cross over like this. Okay. Where oxygen is higher in the alveoli than it is in the pulmonary arteries, so it's going to cross over like this. Okay. So this line right here represents the lining of the alveoli. And this line right here represents the lining of what? The pulmonary vein.
Vein vessel. Yeah.
Mm-hmm. So then the exchange happens, and then the blood vessel becomes the pulmonary veins, and then it carries it back towards the heart. Does that make sense? Questions? Okay. So now in the systemic gas exchange, you have the cells of the body. Now cells of the body need energy, right? Right?
Mm-hmm.
In what form?
ATP.
Yes. How do you make the most amount of ATPs?
Aerobic respiration.
That's right. Which means you need oxygen, and you produce a lot of what?
CO2.
That's right. Okay. So in this instance, yeah, I'm sorry, go ahead.
And water.
Yes, thank you. And water. Okay. So in this one, it's the reverse. The blood vessels, in other words, the arteries, are going to bring oxygenated blood to the cells of the body. So here we have the arteries. It's going to be different types of arteries. For the example, the renal artery, the hepatic artery, and so on. Okay. Then you have the basement membrane that separates it. And then you have the cell that likes to do a lot of metabolic reactions. In other words, it's going to produce a lot of CO2. Okay. And it's going to need O2, which is what, luckily, the blood vessel brings. The arteries bring O2, which is going to diffuse across into the cell so it can produce more ATP. At the same time, it's going to pick up the waste product. Yeah, the CO2 from the cells. And that's how arteries eventually return to the heart through veins and carry deoxygenated blood because it exchanged with cells. Okay, so this set right here that leaves after having exchanged between the blood vessel and the cells, these veins are going to go back to the heart being deoxygenated, high in CO2 and low in O2. Okay, questions? Awesome. All right, Digestive was the other main request. This is perfect timing. So I got about 12 minutes left. So for the digestive, it's a lot. So I really, really highly recommend you going through the worksheet for this one, because the worksheet breaks everything down into the parts, okay? So make sure you know the functions of the digestive system, be able to go through the digestive tract, and that's where you have to know the lining, the mucosa, submucosa, and so on, all the way down, all the way out to the serosa, okay? You need to know the structures, for example, the mouth, the pharynx, the esophagus, the stomach, accessory organs. We kind of do that separately, to the small intestine and then to the large intestine. So as you progress, it's all one tube. It's one continuous tube from the mouth to the anus. But there's a transition in the tissues, the linings, that differentiates one structure from another. So for example, what would you find in the stomach that you would not find anywhere else?
Hydrochloric acid.
Yes,
you
what
talking about
produces the hydrochloric acid?
The parietal cells.
Okay, so you've got the parietal cells, the chief cells. That's unique to the tissue lining of the stomach. You wouldn't find that in the esophagus nor in the small intestine. Okay, make sense?
Yes.
So you need to be able, because that would be the bulk of the test questions that's on this topic. Will ask you about what distinguishing factors one structure has over the other. Okay, so doing that cognitive map that I provided for you on the worksheet, that will help you.
On the quiz, I think I got the gastric pits and the is it ruga?
Yes.
I got them confused. I don't know. Can't remember exactly what the question was, but I guess the pits are where the actual cells are located. Okay.
Yep, where the rugae are, it contracts and expands. Exactly.
Gotcha.
Yep. Yep. Okay. Yeah, so if you do go through like all the parts, the lining of the stomach, you would have gotten that one right. Yep. And don't forget, you can always go back to your quizzes. You can't see the correct answers, but you can see your answers and the question. Okay. All right. So make sure you do go through that. The question that the students in this morning wanted me to focus on was the digestive chemicals. So that's what I'm going to focus on. That's also in your worksheet, but I'm going to go through that with you together here. I have just enough time for that. All right. So the analogy I like to use, because I just love Almond Joys. I really do. They're the best candy. You can argue, but Almond Joys are the best. No, I am serious. If you go hiking, Almond Joys or Snicker bars are the way to go, because it contains the 3 basic, biochemicals that you need in your body.
Protein,
so
fat.
The almonds represent the protein. The chocolate represents the carbohydrates. And the coconut represents the lipids. So it kind of helps us see when and what is being broken down. Okay, so we start in the mouth. The mouth consists of the tongue that helps to move things around, the teeth to break things down mechanically, and the salivary glands to produce the chemicals. So what happens in the mouth? You have functions of ingestion, that's just the eating, and then you have digestion. Now here's the thing, whenever you say digestion, you should always know what you're referring to. Are you referring to a physical digestion or a chemical digestion? In this case, the mouth allows for both physical digestion through mastication, and that's chewing, and chemical digestion, because the salivary glands right here, they produce a chemical called salivary amylase. Okay, and the salivary amylase is responsible for breaking down carbohydrates, which means what part of the almond joy gets broken down right away?
Chocolate.
Yeah, and you can feel it melting in your mouth.
Mm-hmm.
Oh, here's a good excuse to do this. Take a chocolate piece and put it in your mouth. Take an almond and put it in your mouth. The almond does not dissolve in your mouth, but the chocolate does. And now you know why. Because your mouth has salivary amylase produced by the salivary glands, where there's nothing there to break down the protein. Okay. Yep, that's my excuse for eating chocolate.
So what you're saying is I can make a whole meal out of a candy bar. And
that's
be okay.
right.
Great.
It's not the most nutrition, but it's good. Yeah.
I think I'll go with it.
Yeah, I do. All right. So the mouth is the first part. Then you've got the pharynx. Nothing happens in the pharynx. It's just a pathway. Same thing. Esophagus, just a pathway. But when it gets to the stomach, you have digestion. And again, if there's digestion, you have to identify physical, chemical, or both. There is physical digestion that occurs there through the contractions of the rugae. But there's also chemical digestion that occurs there. And whenever there's chemical digestion, you need to tell me what chemical, what does that chemical break down? And where is it produced? Okay, so pepsinogen right here. Remember earlier I told you in the morning, anything with an ogen means what?
Not active or something.
Exactly. Yeah. Exactly. So you have to have hydrochloric acid right here, activating pepsinogen into pepsin before pepsin can break down what?
Protein.
That's right. So that's why when you eat protein, you feel fuller longer because it stays in its intact form, except for the mechanical breakdown, of course, until all the way down to your stomach. So if you were to eat a bowl of rice versus a cut of meat, even if you eat a large bowl of rice, you will feel hungrier. You will feel hungry faster because it starts breaking down right in the mouth already. Where that cut of meat isn't going to be broken down chemically, at least, until it gets to your stomach. Make sense?
Mm-hmm.
Okay. All right. So I did the first two for you. I want you to work on the small intestine and the large intestine. Okay. And then once you do these, check your answers with the answers I give to you in the video. That's why I like to do these review sessions earlier on, so you have time to really dig into your resources. Okay. All right. Okay. So great timing. So we're at 8:57. So any other questions before we're done?
No.
Let me double check my notes to cover that I covered everything that was asked.
On the outline for the digestive system.
Yes, ma'am.
There's a chart on the back for
Yep.
what we just went over.
Yep.
And then on there it says that there's no digestion of lipids in the stomach. That's not right, is it?
So here's the thing. The majority of lipid digestion occurs in the small intestine. But there's a little bit of digestion that does occur in the stomach because, let me tell you the story.
Okay.
So the salivary glands actually produce a substance called salivary lipase.
Okay.
But the salivary lipase is not activated unless it's in an acidic environment.
Okay. Because I thought the gastric lipase and lingual lipase was one that I've got it wrote down in the stomach. Is that not right?
That is correct.
Okay. All right.
So the salivary lipase or the lingual lipase,
Uh-huh.
okay, it's used interchangeably. So that proceeds down to the stomach, along with the gastric lipase. There is little amount of lipase being broken down here.
Okay.
But the majority of the lipase fats being broken down occurs in the small intestine.
With the bile, I guess, I'm assuming.
Yep. And the pancreatic lipase.
Okay.